Hey there, in this screencast, I'm going to go over your Game of 2048 lab, which you should be working on today while I am out. So the first thing you want to do is familiarize yourself with how to play 2048. So in Google Classroom, I posted links to a YouTube video that describes how to play. I also posted links to the Chrome Web Store where you can install one of the 2048 Chrome extensions and actually practice playing yourself. You can also run the completed lab, the jar file for it, and which is what your game will look like when you get it to work. So either way, you should be familiar with how to play 2048. I'm sure there are many people in the classroom who've already played it since it was kind of all the rage 3 or 4 years ago. So check with those people if you're still a little bit unfamiliar with it. Okay, the next thing you want to do is open NetBeans. And then once you open NetBeans, not Greenfoot, this is in NetBeans, go to File, Open Project, and browse over to your Z drive. And everybody should already have a project called Game of 2048 template right on your Z drive. So once you open that, you want to look in the Source Packages folder and then Game of 2048. And then underneath there, you'll see gameboard.java, game of 2048.java, and two other files. You are only editing game of 2048 Java. The graphical user interface for this, all of the code I've already written for you that will interpret the logical code that you write concerning the two-dimensional array that represents the game board. It will interpret the state of that and update all of the graphical aspects of the game for you. So you're not really handling anything graphical. Just like you were in the war game, you weren't really writing the code to make the game appear on the screen. You were just writing the underlying code that drives the game. Okay, so in Game of 2048, there are really only two instance variables in the class. One is called game board state, and it's a 4x4 array of int values that will represent the game board. So in the game, whenever a tile has nothing in it, it will have a 0 assigned to the corresponding position in the two-dimensional array game board state. If there's a 2 tile in a specific cell, the corresponding cell in game board state will be assigned the value 2, same with 4, 8, 16, etc. All right. The only other instance variable is an int variable named score, and that's the score of the game, which you increment every time the player plays and two or more tiles combine. Okay, so there's only one constructor, and it's a no-args constructor. And what it does is instantiate a 4x4 array of int values and assign it to the instance variable game board state. And then it basically adds 2 new tiles to the game. So if you go down to the very bottom, you'll see that add new tile is a method. So in the constructor will actually call add new tile twice. So you'll really add 2 lines of code, add new tile, and then add new tile again. And that's after you've instantiated the two-dimensional array. Now, since when you instantiate an array of int values, if you don't make any assignments to the elements of the array, including both for one-dimensional and two-dimensional arrays, all of those cells are initialized to contain zeros, which is what you want at the beginning of the game anyway, so you don't really need to make any 0 assignments when you instantiate the array. You just need to add 2 new tiles after you do create the array. Okay, so now there are 2 getter methods, and these getter methods are pretty basic. They return the value that is assigned to the score instance variable and the game board state instance variable. So really, they're just going to be a single line of code returning the variable. Okay, so those are 2 getters. There aren't any setter methods. the next one that you need to write is game is finished. So the way game is finished, the way it checks to see if the game is finished is it checks to see if it's possible for the player to swipe right, swipe left, swipe up, or swipe down. And if none of those things is possible, and there are 16 or fewer, let me pause for a second. All right, so you may say to yourself, well, why do you also have to check to see if the number of empty cells is less than 16, in addition to the fact that you have to check to see if they can't swipe up and they can't swipe down and they can't swipe left and they can't swipe right? Well, it has to do something with the graphical user interface, and I don't really need you to understand how that works, so just take my word for it. In addition to not being able to swipe in any of the directions, you also have to make sure that there are less than 16 empty cells on the board. So you'll notice that can't swipe up, can't swipe down, can't swipe right, and can't swipe left are actually methods. So really, game is finished is pretty simple. You just call that method 4 times. You make sure that all 4 of them times each one of those method calls returns false, and that there are less than 16 empty cells on the board. Okay, get random empty location. This is probably one of the more challenging ones. So it returns a 1 by 2 array. Actually, I'm sorry, it returns a 2-cell, 1-dimensional array. And in the 0 position of that cell is going to be the row of a random empty location, and the second cell of the array that it returns is going to be the column of that same random empty location. So what the method then needs to do is compile a list of all of the random empty locations and then randomly choose one of them and return that empty location's coordinates as the return value for the method. So the technique that I ask you to use here is to search through game board state for zeros. So when you find a 0 assigned to any cell in game board state, you will have created a 10, well, actually it would have to be like a 16 row and 2 column array, and each row in that array you're going to store the coordinates of each empty location that you come across. So as you search through the game board state, every time you come across a 0, you record the row in the 0 column of that new two-dimensional 2-column array, and the column of the empty location in the 1 column of that array that you're building as you go along. Once you've finished, and you basically keep count of how many you've discovered as you search through game board state, then once you've finished, you generate a random number based on how many zeros you came across, and you go to that row in your in that temporary local 2-dimensional array that had 15 rows or 16 rows and 2 columns, and you pick out what's in position 0 and 1 for that given row, and you assign those values to position 0 and 1 in that array, that short 2-element array that you're returning. So that's how get random empty location works. It's probably one of the trickier ones to write. Okay, so then the can't swipe methods. How do those work? Well, they return either true or false. And they return true if it's possible for A, there's an empty cell in such a way that there's a cell either below, above, to the right, or left of it, which would enable the user to swipe in that direction. Or there are two cells that are right beside each other in any location on the game board that have identical values. And I should say identical non-zero values. So once you write one of them, the other three are going to be very similar. You're just going to kind of tweak maybe the direction, the for loops that you're using, and if you're looking at columns or you're looking at rows. So if you're doing swipe up, well, you really you want to make sure what you really want to do is check to see if there is any zero tile with any non-zero tile below it. So anytime for any zero that you come across, as long as you find at least one instance where you have a zero with one tile below it, then you would immediately return true. If you don't, also for any given tile, any given non-zero tile, if there is another non-zero tile right beside it, or above or below it, then you also return true. The only time you would return false is if none of those conditions are true and the board has 6. So in that case, the board will have 16 non-zero values. But pretty much you want to look for the true case, and then if none of the true cases are found, then just return false. Okay. Then I have given you the tile for swipe down, swipe left, and swipe right so that you can kind of see basically how the algorithm works and then adjust it for the swipe up method, which is what you're going to write. But in a nutshell, for swipe up, what you're going to be doing is you're going to be looking at rows 0, 1, and 2. And you're going to look at each cell. Excuse me, I have a toddler interrupting me. I am going to pause for a second. So you're going to look at each cell in the first 3 rows and determine what should go there after the user swipes up. So, so for each cell in those 3 rows, the algorithm is you look for the first non-zero tile that's below it. Okay, and if there isn't, and you record that value in a local variable, and if there is no non-zero tile below it, in other words, if there are nothing zeros below it, then you assign 0 to that same local variable. Okay, so once you have found the location and the value of the first non-zero variable, then you have a simple if statement that is going to compare what the current value in that tile is versus what this other non-zero value below it is. And if there's a 0 in the current position, meaning position, row, column of game board state, and you find a non-zero tile below it, then basically that non-zero tile replaces the 0, and a 0 is assigned to that non-zero tile. And then in that case, you also have to decrement the row so that the next time through the for loop, it looks at that same tile again. Because essentially, if you're swiping up and there's a 0 and you swipe a value into it, well, there could be another value beneath the one that you're going to swipe into it that also needs to combine with it. So if I have like 0, 4, 4, in a column and I swipe up, well, the first 4 is going to go up into the 0 position, into the first row, but then the 4 that was right beneath it is also going to go up and combine with the 8. So that means when you replace a 0 in a given cell with another value from a tile below it, or in the case of the other 3 swipes, the corresponding position relative to which direction you're swiping, you need to decrement row before the for loop, before you move on. All right, so if there was a tile, on the other hand, in position row column of game board state, and the first non-zero tile is identical to it in value, then basically you do the combination where you reassign, you double the value assigned to position row column, and then you turn the that non-zero tile below it into a 0. All right, and pretty much that's the algorithm for swiping up. And finally, you'll add a new tile to the game because that's what happens every time you play. Okay, so that algorithm that I just described is the same algorithm that is used in swipe down, swipe left, and swipe right. So really you should be, I think, given that explanation and the fact that you have equivalent methods right below it, just going in different directions, you should be able to write swipe up. Okay, and then finally, the last method that you need to write is called add new tile. So add new tile basically adds a new tile to a random empty location. Okay, so this method basically calls, what does it call? It calls get random empty location, and it either puts a 2 or a 4 into that tile. So how do you determine whether to put a 2 or a 4? Well, you generate a random number, and 90% of the time you're going to put a 2, and 10% of the time you're going to put a 4. All right, and you don't need to worry about there not being a place to add a new tile to when the method is called, because the method will only be called if there is at least one empty tile on the board. So you don't need to worry about the game board being filled when add new tile is called, in which case you wouldn't be able to obviously add a new tile because the game would be over. So yeah, but you do need to call, once again, you need to call get random empty location to accomplish add new tile. Okay, that's it. I think you guys should be able to get a lot of it done, at least the easier parts of it done, certainly the first few methods and maybe add new tile as well. The only tricky ones are really get random empty location and swipe up. The other ones are pretty much not too challenging, and can't swipe methods, pretty much it explains, the comments explain exactly what you need to do. So yeah, so I hope that helped, and when I come back on Wednesday, I'll see a lot of 2048 labs that are pretty far advanced in being completed. And then remember, there's also a homework assignment due on Wednesday, so make sure you complete that, and we will see you then. Cheers.